Okay, exciting topic here, mechanical ventilation. Basically, when people think of mechanical ventilation, they think of my bathroom fan or my exhaust hood in the kitchen. Yes, that is a form of more spot exhaust systems that are required by the residential code, the IRC, and mechanical ventilation is basically another layer of this. And it is especially important because nowadays the codes are requiring that your house is built tighter. Therefore, the tighter the house, the more we want to get fresh air in, but we're controlling that fresh air. So instead of relying on your leaky old house that ventilated itself just fine and probably is not that comfortable, we are building tight and ventilating right. So here are some typical ventilation methods. Okay, so I am in Colorado, climate zone typically 5, 6, occasionally 7. Anyways, in this area, the most common type of ventilation we see is an exhaust only. Essentially, that is your bathroom fans that are running continuously at a super low rate. I'll show you that rate at the end here. But that's like the most cost-effective, easiest way to achieve the requirements. We built the tight house. Now let's ventilate it. Yes, windows are a form of ventilation. That is natural ventilation and it can be used. But keep in mind that windows, it depends on how windy it is outside, the temperature difference. You can't control the amount of air that's gonna go through that window. Also, that window cannot filter out any dust, any pollen, any critters, any people that wanna intrude, some burglars, I don't know. It also can't filter out any noise or rain. So that is why we want to basically take control how we're capturing that fresh air and how we're dispersing it throughout the house. And also code does not require or does not allow natural ventilation as a means to achieve your whole house ventilation. They do require that there is mechanical ventilation. So here we go. I like to think of mechanical ventilation like your lungs. Right? So our lungs are supplying air to the rest of our body and it's a dedicated system. Let's take it one step further. You have the ability to breathe through your nose or your mouth. What's better? Your nose, by far. Your nose is filtering through all your nose hairs. It's filtering that air. It's also conditioning that air and therefore making it easier for your body to basically disperse that air throughout your body. If you mouth breathe, this reduces the amount that you're filtering that air. Also, if you mouth breathe a lot, this is detrimental to your health. You can have dental issues, sleep apnea, learning disabilities, whatnot. So nose breathing recommended over mouth breathing. Let's also equate mouth breathing to basically supply only type of ventilation. So you're dumping fresh air into the house, but you're not really filtering it and you're not really conditioning it. If you are nose breathing, that's more of your ERV, HRV, okay? You're really controlling that air, filtering, conditioning, all the good stuff. Let's also think about filters and the importance of changing your filters. If you have a really snotty nose, it makes it really hard to breathe. This is equivalent to a clogged filter. So definitely clean those filters or swap them out, get that, just keep it fresh. All right, so technically the code allows all of these methods to achieve your whole house mechanical ventilation. There are, however, if you are in climate zone 7 or 8 and you're under the 21 energy code, you have to have the ERV, HRV balanced ventilation type. Also, you wouldn't want to just totally inhale or totally exhale because you can't function. Same thing with the house. If you are exhausting only or supplying only, you know, say you're supply only, your house is under a positive pressure. If you're exhausting only, your house is under a negative pressure. We'll get into that. Okay, exhaust only. Bathroom fans, just exhausting air. And that's typically okay, but really you're just exhausting all that air that you just worked hard to condition to either heat or cool, and now you're just exhausting it outside, and that air has to be replaced by other air that needs to be reheated or recooled. And that incoming air is typically not filtered and not controlled. You know, it's coming in through the cracks of your house is the thought process behind this. And if your system is not running continuously, you'll have to have a damper on the exterior so you don't just have a hole in your now airtight home. So that's just another aspect of this. Probably the most important reason you don't want an exhaust only system is if you are not all electric and you have open combustion appliances and equipment. That is a huge risk to backdraft these gases into your house. So it's very harmful. You just don't want to have your house under negative pressure and have open combustion equipment. These systems are most common in cold climates. If you want to do the system in a warmer climate, that may be an issue for mold. So you're basically asking that warm, moist air on the exterior to be drawn inside, and that can possibly condense in your wall assembly. All right, so let's talk about supply only. This around these parts, this is essentially a fresh air duct that's ran from the outside and tied into the return of a forced air system. Again, kind of more of the mouth breather of the options, and you're basically diluting the existing air. And this also adds another layer because you don't want to just dump all that fresh air in. You have to have a damper on the outside, and you have to have a way to control how much air is actually going into that system. Now, in warmer climates, this is a supply only system is more common. It's just a fresh air duct with a filter and a fan that pulls the fresh air from the outside and supplies it to the most occupied rooms, your bedrooms, living room. Your backdrafting of the appliances would typically not be an issue because the house is pressurized. So that is an advantage. But again, you don't want to do this typically in colder climates because your warmer, moisture air in the interior of the house is now being pushed to the outside. Thermodynamics here, you know, it's always hot to cold, more to less. That's how we're thinking. So the balanced ventilation, this is achieved basically by combining your supply only, exhaust only. You are supplying fresh air, and this is essentially talking to your exhaust system saying, hey, I'm dumping this much fresh air in, let's exhaust that equal amount of. And I have some examples of this. Would be like a Panasonic Select Cycler tied to the Panasonic Whisper Green fans. So that cycler, it's a damper, it opens when you need fresh air, it talks to the fans and they'll exhaust. So you have a balanced house, which is nice. But again, it's a little complicated. You could also just install an ERV or HRV. This is energy recovery ventilator or heat recovery ventilator. The energy recovery ventilator deals with humidity. The heat recovery ventilator is just heat. So both ventilating, but the ERV is transferring heat and moisture, and then the HRV is just the heat. So think about, and I'll zoom in on this here, but there's a core, and basically the ERV is exhausting while supplying at the same time. It's going through a core, and that core is transferring the temperature of the inside air to the outside air. So you have a transfer efficiency, essentially, so you're not just dumping cold air or warm air in the house. So, and this efficiency is typically around 65% is the minimum. If you want to go a step higher, the code would require 75% efficiency. A unit, like a Zender unit, is closer to 95% efficiency. So that's pretty neat. So typically the ERV is recommended in a drier climate because you want to maintain that moisture in the house, where in more humid climates you're trying to dehumidify, right? So you would go with the HRV. So just a quick example. So in the winter, the stale, warm indoor air is being exhausted, dumping. Oh wait, hang on. So there are different ways to duct your ERV or HRV, and some installers want to connect this to the existing ductwork because it's already there. Just, tie it in. The issue with this is that there could be some weird pressure differences. So if you are tying it into the existing system, be wary that it might not be totally balanced. But if you install the ERV, HRV totally on its own, that's the way to go. Because it doesn't depend on what's happening with the distribution of the heating and cooling. It's just supplying the fresh air and exhausting stale air. It's doing its job. And what's really cool is you can tie your bathroom exhaust fans into it. So instead of exhausting each bathroom fan to the exterior, poking an extra hole to the outside, you can tie this into the ERV. And then basically if someone goes to the bathroom, wants to ramp up that fan, the whole system ramps up. So it stays balanced, and that's just the way to go. I'll show a photo here basically telling you how much the code requires for ventilation. It's not a whole lot, and honestly, you don't want to overventilate, because if you overventilate, then you have an efficiency hit, right? Now you're just, dumping too much air to the outside, bringing in too much fresh air. You really just need the minimum, which I'll show you here. So to conclude, fresh air is necessary, and it's best to control, filter, and disperse this air instead of relying on natural ventilation. Supply only is more common in warmer climates. Exhaust only is more common in colder climates, but should definitely not be used with any open combustion appliances. Balanced ventilation can be achieved by combining a supply only, exhaust only, or you can use the ERV, HRV. An ERV handles the latent load or humidity, and you want that in your drier climates. HRV, good for more humid climates. Keeping that mechanical ventilation separate is ideal. The amount of ventilation is determined by the codes. Again, nose breathing over mouth breathing, ERV, HRV over exhaust only or supply only. Thank you for watching, and I hope you'll subscribe. YouTube at Yeti Cooler House 953, and then here's some Instagram. We're just at Yeti Cooler House, and my business is at @fullcircle_aeroseal. So thanks. See you guys soon.